All right, we're going to consider the differential equation. The derivative of y with respect to x equals 3x squared e to the second. And you can't really tell, but that's a y there. So it's, if I rewrite this equation, it's 3x squared over e to the 2y. All right, so we're looking for a solution to the y equals f of x for the differential equation, satisfying the point 0, 1/2. All right, so we have to separate our variables. When you do that, you're going to end up with e to the 2y dy equals 3x squared dx. We integrate both sides. All right, the right-hand side is pretty fast. It's just 3x cubed over 3 plus c, or x cubed plus c. This left-hand side requires a little more work because we've got the inside function of 2y. So we actually have to do integration by substitution for that guy. I'm just going to scroll down here so I have some space. So our u, our inside function, is 2y. du with respect to y is 2. All right, if we're doing it the way that some of you are accustomed and seem to prefer, dy equals du over 2. So substituting in, I'm going to have the integral of e to the u du over 2, or 1/2 the integral of e to the u du. 1/2 integral of e to the u is e to the u. And substituting back in, we have 1/2 e to the 2y. So my integral here, 1/2 e to the 2y. And we were instructed to look at the point 0, 1/2. So we're going to go ahead and substitute that in. I've got half e times 2 to the 1/2, 2 times 1/2 equals 0 cubed plus 3, plus c, my bad. So we got c equals 1/2 e to the 1, so 1/2 e. So my equation then is I've got 1/2 e to the 2y equals 3, whoops, my bad, x cubed plus 1/2 e. All right. We're going to have some monkey business going on here because we have to solve for y. So we're going to multiply through by 2. So I got e to the 2y equals 2x cubed plus e. And then we're going to have to do the natural log of both sides to get rid of that exponential e there. So I've got 2y equals natural log of 2x cubed plus e. I know it doesn't look the prettiest, but, and then we're going to divide by 2. So our solution is 1/2 natural log of 2x cubed plus e. Now we need to find the domain of this function for the second part. So domain and range. So range of let's just think about the parent function, natural log. So natural log x looks something like this, our parent function. All right, so the parent function has a domain of 0 to infinity because we can't put in 0 or negative numbers, and a range of -infinity to infinity. So my range here, regardless of how I move natural log up and down, left to the right, is still going to be all real numbers, or negative infinity to infinity. Our domain is going to be a little trickier because we can't have any values less than 0. That's what this says, right? So this says x has to be greater than 0. So what we're thinking about now is we can't put anything in that's equal to 0 or smaller. So we can't put anything in here that's equal to 0 or smaller. So for our domain, we're going to have 2x cubed plus e greater than 0. 2x cubed greater than negative e. Divide both sides by 2, you've got x cubed greater than negative 1/2 e. And then x greater than negative cube root 1/2 e. And that's our domain. All right, that's it, folks.